Okay, so good morning, good afternoon, and good evening for all of you. I don't know whether when you are watching this video, so I greet from all of these three. Yes, so today we are going to study about the 22nd lesson sets in grade 9, the 22nd lesson sets. Yes, before moving to this lesson, there is a small description or small introduction, and with the previous classes, previous grades, you have learned about sets, to how to write sets. So you know you can write these sets in a curly bracket like this. So if I write a set of even numbers between 0 and 11, if I write even numbers between 0 and 11, I can write even numbers is 2, 4, 6, 8, and 10. So this is the set of even numbers between 0 and 10. Next, we can write the prime numbers like this: 2, 3, 5, 7. Yes. So these are the prime numbers which are lesser than 10. Which are lesser than 10. You can tell it like that. These are the prime numbers, the set of prime numbers which are lesser than 10. Okay. So there are few numbers. So there are few things written here using commas. Here, these are written using commas. So these are called the elements of this set. These are called the elements. These are the elements of this set. So here 2, 4, 6, 8, 10. Those are the elements of this set. And in the next set, 2, 3, 5, 7 are the elements of that set. Okay. So when we go ahead, we can write. So when you write the sets, you must definitely put this curly bracket, not the normal bracket. You must put the curly bracket. Okay. So if I say something like that, if I say simple A is an element of set A, is an element of set capital A. So that one we can denote as simple A is an element of capital A. So we can denote it like this way. So this means simple A is an element of set of capital A. Again, I will repeat it. Simple A is an element which belongs to the set capital A. So we can denote it like this way. Okay. So as we have studied in that probability lesson, so I think you can remember, we have studied something like this: NA. Yeah, we have learned something like this way. So this means the number of elements in set A. Number of elements in set A. So if I think this is A, this is the set A. Sorry. If I say this is the set A, this means the number of elements in set A. Number of elements in set A. So you can count 1, 2, 3, 4, 5. There are 5 elements in this set A. So NA is equal to 5. So this is a small introduction what you have learned in previous grades. Yes. So there are few methods to describe the sets. So in this lesson, we'll try to learn all of these, not all of these, most of these methods. So yes, before going to these methods, I have to discuss about the null set. So I think you have already known that one, null set. Null set means a set which do not have any elements in that set. Null set means, so null NULL set. Null set means there are no any elements in this set. there are no any elements in this set. So if I say like this, so A is a set, so there is no any element. There is no any element. So I can denote it as A is like this way, a bracket like this. What means a blank bracket like this. So there is a blank, so there is no any numbers or elements. So this way you can denote a null set, and also you can denote a null set like this way. A is equal to like this way. So this is also a null set. This is how we can denote this by using symbols, this one and this one. So you can use either one of these methods. And can anyone tell me this one? In this one, NA, can anyone tell? Yes. If you can get the answer, good. Number of elements in A. Number of elements in A. So now I'm considering about this set, not about this set. So don't mess up it. So now I'm talking about this set A. Okay. Number of elements in A. So you can see there are no any elements in this set A. So that means the number of elements, or NA, is equal to 0. So the number of elements in this set A is 0. So I think you can understand it well. So shall we move to a small example? So I think you will get a proper idea when we do this example. So if you need to write anything, you can write it. Any note, you can write it. Okay. So example number 1. If P is equal to even prime numbers between 5 and 10, then find NP. So here they tell about even prime numbers. So shall we see even numbers between 5 and 10? Even numbers are 6, 7, 8. So both 6 and 8 are the even numbers between 5 and 10. And prime numbers. So they must be even prime numbers. So here 6 is not a prime number, 8 is not a prime number. That means there are no any numbers which are even and prime between 5 and 10. So that means we can write P is equal to, here there are no any elements inside this P set. So they ask number of elements in P, NP. So it is equal to, here no elements, that means it is 0, because this is a null set. So I think you can understand it well. Okay, so shall we do a small review exercise? In your textbook, there is a review exercise, and shall we do only one question? That is, shall we do the second question? So I think you can do the other questions. So I will only do the second question now. So this is the second question. So you can pause this video, and after that you can try to write the answers for this question. Okay. So I will start writing the answers for this question. Question is, write each set given below in terms of its elements and write the number of elements in each set too. Okay. Okay, so shall we move to first question, first part? They have given A is equal to multiples of 5 between 0 and 20. So we can write A is equal to multiples of 5 between 0 and 20. Between 0 and 20. So we cannot take 0 and 20. So they must be between 0 and 20. So you can say 5 is a multiple of 5. So then 10, next 15. So these are multiples of 5 between 0 and 20. We cannot take 20 because they have told only to take between 0 and 20, not 20. We can take the numbers between 0 and 20. So this is the value. And here in the question, they have told write the number of elements in each of the set. So we can write NA is equal to here. There are 3 elements. That means 3 is the answer for this one. Okay. Shall we move to our next part? Letters of the word reconciliation. Reconciliation. Okay. So letters of the word here you can see there is a word. So shall we write them as a set? Okay, so when we write this set, we can say B is equal to, so shall we see the letters in this word reconciliation? So we can say here R is there, okay, E, C, O, N, R, E, C, O, N. Next, C we have written it already, and I, L, I, L, again L we have written, I we have written, again A, next T, so we haven't written, yes, T. Next, I we have written, yes, O we have written, and again N, yes, we have written. So this is the set of letters in this word reconciliation. So yes, so this is the set, so we can write number of elements in B is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 elements. So this is the answer for second part. Next one, third part. C is equal to prime numbers between 2 and 13. So you know what are prime numbers. So we can write prime numbers between 2 and 3. Between 2 and 3. So we cannot get 2 or we cannot take 13. So the numbers between that 2 and 13. So 3 is a prime number, 4 is not a prime number, 5 is a prime number, 6 again 7 is a prime number, 8, 9, 10, 11 is a prime number again, and 12 no, 13 is a prime number. So but we cannot write because we have to write between 2 and 13. Okay, so this is the set. So 1, 2, 3, 4. So we can write number of elements in C is equal to 1, 2, 3, 4. So this is the answer for third part. Fourth part. D is equal to numbers between 0 and 20 which are a product of two prime numbers. Again, shall we see? Number of numbers between 0 and 20 which are a product of two prime numbers. Which are a product of two prime numbers. Yes, so we can say it like this way. So 0 and 20. So 1 is 1 multiplied by 1. So this is not a product of two prime numbers. Next, 2. Yes, 2 is 2 multiplied by 1. So they ask product of two prime numbers. Here, 2 is a prime number, but 1 is not a prime number. So this is not an answer for this set. So shall we take 3? 3 multiplied by 1? No. So this is also not. There are no two prime numbers. There is only one prime number because 1 is not a prime number. Please keep it in your mind very well. 1 is not a prime number. Okay. 3. Next 4. Yes, 4 is correct. 2 multiplied by 2. So both are prime numbers. So it is 4. 5. No. 6 again. Yes. 6. 7. No. 8 is numbers between 0 and 20 which are a product of two prime numbers. So shall we see 8? 8 is 4 multiplied by 2, or else you can take 8 multiplied by 1. So here this is only one prime number, and here also there is only one prime number because 4 is not a prime number. So we cannot take 8 also. 9, no, there is no two prime numbers. 10, yes, we can say 10 is 5 multiplied by 2. So both are prime numbers. So 10 can be taken. 10, 11, no. 12 we can write 4 multiplied by 3, so 4 is not a prime number. Again 12 can be written as 6 multiplied by 2, 6 is not a prime number. So yes, 12 also cannot be written as a product of two prime numbers. 12, 13 no, 14 yes, 14 we can write it as 7 multiplied by 2. 7 multiplied by 2 yes, then 14 we can get as an answer, both are prime numbers. 14 and next 15. 15 can be written as 5 multiplied by 3. 5 multiplied by 3 means 5 and 3 both are prime numbers. So we can write 15 also a product of prime numbers. 16 we can write as 4 multiplied by 4, but both are not prime numbers. Again we can write 8 multiplied by 2, but 8 is not a prime number, so we cannot take 16. Next 17, so we cannot take 17. Next is 18. 18 we can write 9 multiplied by 2, but 9 is not a prime number. Again we can write 6 multiplied by 3. 6 multiplied by 3, so we cannot say 6 is a prime number, so it is also not correct. Again 19, so no, it is only one prime number. Yes, so these are the only things that can take as the set of the numbers between 0 and 20, which are a product of two prime numbers. Okay, so we can write number of elements in D, it is equal to 1 2 3 4 5. ND is equal to 5. So this will be the answer for this question. Okay, so next what we are going to do is we are going to define some names for these sets. We are going to define few names for these sets. Yes, so first of all, shall we define it as finite and infinite sets? Yes, you can write the topic, and if you need, you can note it down. Finite sets and infinite sets. Finite sets and infinite sets. So shall we see what are these finite sets and infinite sets? So before before writing, we can express, or we can tell it like this. Finite sets mean so I think you know what are the meanings of finite and infinite. So finite means sets which have a specific number of elements. Sets which have specific number of elements. That means we can say in this set there are 5 number of elements. In this set there are 10 10 elements. In this set there are 10 elements. But some sets are there is no any specific number for that set. So yes, shall we take 2 examples like this way? So I will take 2 examples. A is equal to multiples of 5 between we can say 0 and 20. Next one I will take another set. Next one I will take multiples of 5 only. Multiples of 5. So if you write the element, so for this one we can write A is equal to multiples of 5 between 0 and 20. So between 0 and 20 means 5, 10 and 15 only. So you can see there are only 3 elements in this set. Next one here, B. B is equal to multiples of 5. So multiples of 5, so we can start from 5, 10, 15, 20, 25, 30, 35, like that way you can continue. There is no any limit, or there is no any end for this, because they haven't defined any end for this set. So you can say 5, 10, 15, 20, 25, like that way you can go ahead and you can go to 1 billion, 1 trillion, 1 million or any other numbers. So you can continue like that way. So there is no any specific number of elements in this one. There is no any specific number of elements. මෙන්න මේ set එකේ හරියටම elements ගානක් නැහැ. So here you can see 5, 10, 15 and it will continue like this way. Because of that I have put a few dots here. So it can continue like this way in this pattern. But here if you see the set A, there is only 3 elements. However, there are only 3 elements. So here in this set A, there is a specific number of elements. There is a specific number of elements, and here in the B, there is no any specific number of elements. So there can be any number of elements. So there is no any specific number of elements. So if there is a specific number of elements, we say for that those are finite sets, not infinite. Those are finite sets. And if these sets does not have a specific number of elements and there can be many elements, we say infinite sets. Say infinite sets. So yes, if you want, you can write it down. Yes, I will explain these two again. Finite sets means if you write all the elements of that set, and if that set has only a specific number of elements, if that set has only a specific number of elements, so we say those as finite sets. And if those sets do not have a specific number of elements, and if those sets have many number of elements and there is no any specific number, we say as infinite sets. Set එකකට specific number එකක් තියෙනවා. Specific number of elements තියෙනවා නම් අපි ඒවට finite sets කියලා කියනවා. Set එකකට specific number එකක් නැත්නම්, specific number of elements නැත්නම් elements ඕනි තරම් තියෙන්න පුළුවන් නම් we say infinite sets. So I think you can understand it now. Okay, to understand this well, shall we do a small example? So this is in your textbook, and shall we do that example so you will get a better idea about this set. Yes, I will get this example like this. So this is the example. So shall we try to do itself now? For each of the sets given below, write the elements and write whether it is a finite set or an infinite set. So shall we see P and Q? So I haven't given it. So yeah. So these are the two sets. Yes, shall we see? Set P. P is equal to positive multiples of 6 less than 30. So we can write this set as P is equal to positive multiples of 6. Positive multiples of 6. That means we can take 6 multiplied by 1, 6, 12, 18, 24, and can we take 30? No, because they have told less than 30. So less than 30, it must be less than 30. So this is the set. So you can see there is a specific number of elements. That means there is only 4 elements in this set. So we can say this is a finite set. Next one, Q is equal to polygon. Q is equal to a set of polygons. So polygons, what are polygons? So I think I have done this lesson for you, angles of a polygon. So polygon means there can be any number of sides. So we can start from a triangle. triangle, and if there are 4 sides, quadrilateral. Next one, if you have 1, 2, 3, 4, 5 sides, it will be pentagon. 5 sides, 6 sides, it will be hexagon. Like that way, it will go on, and heptagon, octagon, dodecagon. Like that way, it will go up to many. That means there will be no any limit. අපිට polygons ගත්තාම sides ඕනි තරම් තියෙන polygon එකක් ගන්න පුළුවන් නේ. sides 3ක් තියෙන polygon එකක් ගන්න පුළුවන්. sides 4ක් තියෙන polygon එකක් ගන්න පුළුවන්. sides 5 6 7 8 10 20 100 150 500 1000 ඕනි තරම් ගන්න පුළුවන්. ඕනි තරම් sides තියෙන polygons ගන්න පුළුවන්. So you can understand there is no any limit for this set. There is no any limit, and it will be unlimited. So here there is no any specific number of elements. There can be many elements, and there is no any specific number of elements for this set. So that means from that one we can say it is a infinite set. Infinite set. So I think you can understand it now. Okay, so shall we move to our next topic? Our next topic is equal sets. So we have discussed now finite sets and infinite sets. Now we are going to discuss about equal sets. Equal sets. Okay. Equal sets means, yes, you have the idea now. Equal means they must be the same. They must be the same. So yes, shall we? No, before going for an example, shall we try to understand it like this way? Equal sets means if there are 2 sets and the elements of these both sets are equal. If the elements of these both sets are equal, we can say these 2 sets are equal. Sets දෙකක් ගත්තාම ඒ sets දෙක ඇතුලේ තියෙන elements equal නම්, ඒ ඇතුලේ තියෙන elements ඔක්කොම equal නම් අපිට කියන්න පුළුවන් these 2 sets are equal sets. So you can write if you want anything. Yes, so shall we take a small example? So if you need to write anything, you can write. You can pause this video and you can write. So what do you mean by equal sets? Means if there are the same elements in both of the sets. If there are the same elements in both of the sets, yes, those sets can be told as equal sets. Shall we take this small example? Shall we try to write it? Shall we try to write the answer? Set A. Set A is even numbers between 0 and 10. Even numbers between 0 and 10. So it will be 2, 4, 6, and 8. Next one. B. Digits of number 4, 8, 2, 6, 8. 4, 8, 2, 6, and 8 is here. So we don't want to write 8 again. Yes. So if you see here, 2, 4, 6, 8. And here also 2, 4, 6, 8. Elements are the same. So we can say these 2 are equal sets. And the order of the elements you will not need to consider. The order of the elements it is not considered. මේ set දෙක ඇතුලේ තියෙන elements වල order එක අපි consider කරන්නේ නැහැ equal sets අපි හොයද්දි. So the elements are the same, 2, 4, 6, 8 for both of these sets. So we can say A and B are equal sets, or you can write A is equal to B. A set is equal to B set. So this is how we denote it. So we can say A and B are equal sets. So I think you can understand it. So if you need to write anything, you can pause the video and you can note down anything. Okay. Next, we move to another special topic. It is equivalent sets. Equivalent sets. So shall we write that topic? Equivalent sets. Equivalent sets. So this is little bit different from the last one. Last one we have told about equal sets. So if those are equal, the elements must be same in both of the sets. The elements must be the same in both of the sets. Now we are going to discuss about equivalent sets. Equivalent sets means, try to understand it well, the number of elements in this set must be equal to the number of elements in the other set. If there are two sets and the elements can be anything different or same or anything, but the number of elements in this first set must be equal to the number of elements in this second set. So we can say these two sets are equivalent sets. So I will repeat it again. If there are two sets which their number of elements are the same, not the elements, number of elements are the same, so we can say those are equivalent sets. So I think you can understand. So shall we take a small example? So if we take an example, it is easy for us to discuss. So shall we take this example number 2? Here, x is odd numbers between 0 and 10. So shall we write x is equal to odd numbers? That means 1, 3, 5, 7 and 9. Okay. Next one, y is vowels in the English alphabet. So you know A, E, I, O, U. A, E, I, O, U are the vowels in the English alphabet. So here x, we can take nx, the number of elements in x, it is 5. The number of elements in y, it is also 5. Now we can say, because equivalent set means not the elements, the number of elements must be the same. So you can see here, elements are different from each other, but the number of elements are the same in both of these elements, both of these sets. The number of elements are the same. So we can say this set x and set y, those are equivalent sets. So we can say x and y are equivalent sets. Yes, so this is how we can identify this equivalent sets. So I think you can understand it. So if you have any question, you can ask me anytime in the WhatsApp. Yes, so shall we go ahead and yes, there is exercise 22.1. Shall we do few questions from this exercise 22.1? Okay, so as I referred to exercise 22.1, I can see there are 5 questions, and yes, I think it is very easy, and yes, so you can do those that exercise 22.1. So if you have any question, you can ask me in the WhatsApp, or else you can do this question or the exercise and send me as a PDF, so I can check your answers also. So I think you can do it by your own. So because of that, I will not explain this, and I will move to the other part of this lesson. So we have to now discuss about the universal set and the subsets. Universal set and the subsets. So first of all, shall we write what are subsets? So shall we write a topic, subsets? Okay, subsets. So I will explain it like this way. So there are two sets like this way, A and B. Yes, think there are elements in this bracket, inside this bracket. So this is the thing you have to understand. Yes. Subsets means, so this set A also have elements, set B also have elements. So if all the elements in set A, sorry, I repeat it. If all the elements in set B, if all the elements in set B are inside the set A also. Again, I will tell, if all the elements in set B is inside the set A, we can tell that B is a subset of A. B is a subset of A. So I will again tell it in Sinhala. B කියන set එක ඇතුලේ තියෙන ඔක්කොම elements B set එක තියෙන B set එක ඇතුලේ තියෙන ඔක්කොම elements A කියන set එක ඇතුලේ තියෙනවා නම් B කියන එකේ elements ඔක්කොම A කියන set එක ඇතුලේ තියෙනවා නම් so we can say B is a subset of A. B is a subset of A. B is a subset of A. So I think you can understand it. So shall we take a small example and see how we can identify these subsets? So we can take a small example like this. A is equal to 1, 2, 3, 4, 5, 6. B is equal to 2, 4, 6. So you can see 2, 4, 6. This all the elements are included in this A set. A කියන set එක ඇතුලේ මේ B කියන set එකේ ඔක්කොම elements තියෙනවා. 2, 4 and 6 here. 2 is here, 4 is here and 6 is here. So we can say all the elements are inside A. All the elements of B are inside A. So now we can say B is a subset of A. B is a subset of A. Subset of set A. Or we can say set B, we can say a set B is a subset of set A because all the elements in B is included in A. So we can say set B is a subset of set A. Yes, so there is a special notation for this, how to denote this subset. So we can say yes, we can write it like this way. B is a subset of A. So in the previous we have learned element. So here element. So where is that? Here we have learned if simple A is a element of set A. If simple A is a element of set A, we can denote it like this and don't mess it up. So now what we are discussing is B is a subset of A, not an element. B is a subset of A, so we are not writing this E or this sign. We are not writing this middle. We are not yes putting this middle line. So it will be like this. So we can tell B is a subset of A. So it is denoted by this sign. B is a subset of A. So please keep it in your mind because there are questions with using these signs only. They do not tell anything about that as a description. They will give the sign like this. එයාලා මේම sign එක විතරක් දීලා තියෙන්න පුළුවන් description එකක් දෙන්නේ නැතුව. So you have to understand well what this sign means. මේ sign එකෙන් කියන්නේ මොකක්ද කියලා ඔයාලා හොඳට දැනගෙන ඉන්න ඕනේ. So please keep it in your mind. Okay, shall we do few examples from that one because it is very much important. So shall we go to example number 1? Example number 1. Shall we do it fast? So as this is a big lesson, I have to do it fast. Yes. So example number 1. So you can pause this video and try this. Yes. P and Q. Yes. P. Shall we write P? P is equal to multiples of 6 between 0 and 20. So we can say 6, 12 and 18. And also Q. Q is equal to multiples of 3 between 0 and 20. So we can say 3, 6, 9, 12, 15 and 18. Yes. So we can see here 6, 12 and 18. So these are included in this set. That means this all the elements are inside this set Q. That means we can say P is a subset of Q. P is set P is a subset of set Q. Or we can write it using that notation. P is a subset of Q like this way. So both of these are correct. So this is example number 1. Shall we move to yes, shall we move to example number 3? Example number 3. So it is a little bit different question, so I will explain it to you. So what they ask is write all the subsets. So now they do not ask is this one is a subset of the other one. Now they ask to write all the subsets of the set Y3, 5, 7. Yes. So you can take that subset means that the other set must include one or so no, I can tell it like this way. The other set must include few or all of these elements in this set. අර අපි පස්සේ ගන්න සෙට් එක ඇතුලේ මේ මුලින් දීලා තියෙන සෙට් එකේ ඔක්කොම නැත්තම් elements කිහිපයක් හරි පෙන්නලා තියෙන්න ඕනේ. So we can write subsets of this one as, so definitely you can take the null set. Definitely you can take the null set because this null set is included in this one. So how can you say null set means there are no any elements. So here we can take inside this one also. Inside this one also we can say there is what there is a thing that is with the null set. So there is no anything as a null set. So shall we try to explain it further? Okay. However, try to understand it. When we write a subset, we can get null set also a subset of this set. We can take the null set also a subset of this given set. Okay. So here, next one we can take 3 only, and we can take 5 only as a subset. Next one we can take 7 only as a subset. Next we can take 2 of them, 3, 5 as the subset. Next we can take 5, 7 as the subset. Next again we can take 3, 7 as the subset. And next you can take all of these all of these elements also as a subset. So you can see 1, 2, 3, 4, 5, 6, 7, 8. There are 8 subsets you can write from this. There are 8 subsets you can write from this Y set. So definitely there can be the null set, and there can be each of these as subset, and you there can be 2 of these elements like this, and there can be all these elements as a subset. So I think you can understand. So write all the subsets. So these are the all the subsets in this Y3, 5, 7 set. So I think you can understand it well. Okay, So now we are going to discuss about universal sets. So we have discussed about subsets. Now we are going to discuss about universal sets. So it is as that inverse of that subset. Subsets කෙනෙක් කෙනාගේම අනිත් පැත්ත වගේ තමයි universal sets කියලා කියන්නේ. So subsets means there is a part or the full set of another set. තවත් set එකකින් මොකක් හරි පොඩ්ඩක් නැත්නම් ඒ ඔක්කොම elements අරගත්තාම තමයි ඒක subset එකක් වෙන්නේ. So this is the other thing. So if there is a set given, if there is a set given, and if we can put all these elements to another set, if we can put all these elements into another set with many large elements, we can say that set as a universal set. So I think I will do an example and say or explain it to you, and yes, I will explain in Sinhala also. මොකක් හරි set එකක elements තියෙනවා නම් මොකක් හරි මම හිතනම් A කියලා set එකක් තියෙනවා, මොකක් හරි A කියලා set එකක් තියෙනවා, A කියලා set එකක් තියෙන එයාගේ ඇතුලේ තියෙන ඔක්කොම elements මෙන්න මේ B කියන set එක ඇතුලේ තියෙනවා AY තව ඕනි තරම් elements තියෙන්නත් පුළුවන්. මේ A එක ඇතුලේ තියෙන ඔක්කොම elements මේ B එක ඇතුලේ තියෙන්න පුළුවන්, තව B එක ඇතුලේ තව ගොඩක් elements තියෙන්නත් පුළුවන්. මේ ඔක්කොමත් එක්ක තව elements ගොඩක් තියෙන්නත් පුළුවන්. So such these sets are called universal sets. This B can be taken as a universal set. So shall we do a small example so you can get this idea very well. Shall we take this one? Write a universal set for A. A is equal to 2, 4, 6, 8. So if you write a universal set, we can tell or we can yes. So there is a special sign for this universal set. It is this one, not 3, the other side of 3, like it is the other side of 3, like this way. So this is the symbol we tell this as the universal set. So this is denoted by universal set. So universal set we can tell here 2, 4, 6, 8 is only there. Only 2, 4, 6, 8 is only A, and this 2, 4, 6, 8 must include in this universal set, as well as there can be many other there can be many other numbers. So if I write like this way, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, so you can see 2, 4, 6, 8 all are included in this set, and as well as this have much more elements. This universal set has much more elements. So you can say as an example 1, 2, 3, 4, 5, 6, 7, 8 means numbers between 0 and 10. 0 and 10. So we can say this is the universal set of this one, of this A. We can say universal set as this one. Even you can write another universal set like this way. So what is the special thing is you must include all these elements inside this universal set. 2, 4, 6, 8, and also you can take another 10, 10, 12, 14, 16, 18. Yes, like that way you can take the universal set, because here all the elements are included in this one. So you can write this as a description: even numbers between 0 and 20. Even numbers between 0 and 20. So I think you can understand it. So you can write any number of universal sets for a given set. You can write any number of universal sets. but it must yes, definitely this all the elements must be included in this universal set. So it is only valid if all these elements are inside this universal set. Okay, so I think you can understand it well. So shall we see whether can we do a exercise? Okay, okay. So exercise 22.2, shall we take this second question and third question only? Second question and third question. So shall we do it fast? Exercise 22.2. Shall we do it fast? So you can pause this video, and after that you can do, and you can check for the answers. Okay. So shall we see? Determine whether each of the following statements is true or not. Each of the following are true or not. So you can you know this symbol. The symbol is a subset of here. This first one is a subset of this second set. Shall we see? 1, 2, 3. And here numbers divisible by 5. Here 1, 2, 3 is here. 1, 2, 3. And numbers divisible by 5, you can take 5, 10, 15, 20 like that way. So is this correct or wrong? Is this correct or wrong? So is this a subset of this one? No, because 1, 2, 3 are not included in this set. 1, 2, 3 are not included in this set. So we cannot say this is a subset of this second set. So this is not true, it is false. The first one is false. 4, 9, 16 square numbers. Yes, 4, 9, 16 is the first set. The second set is square numbers. So there is no any limit. So square numbers we can write 1, 4, 1, 4, 9, 16, 25, 36, and you can write more in this set. So you can see this all the elements are included in this set. This all the elements are included in this set. So you can say this is a subset of this second set. First set is a subset of this second set. So yes, we can write it is as true. Next one, cylinder, polygons. Cylinder. Cylinder means cylinder is a like this way one. But polygons means what? Polygons means a plane figure. So cylinder means a solid, but polygons mean a plane figure like this way. Plane figure, but here cylinder is a solid, so we cannot say solid this cylinder is a subset of this polygon. We cannot say cylinder is a subset of this polygon, so we cannot say. So this is false. Next one, red, colors of the rainbow. So I think you know the colors of the rainbow. Colors of the rainbow. So if you can remember, can you tell me VibGeo? So I have remind, or I have remember is in this way VibGeo. So in this rainbow there are 7 colors: 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. V means violet. I means indigo. B means blue. G means green. Yeah, Y means yellow. O means orange. And R means red. So these all the colors are indicated in this second set. So you can see this first set, all the elements of this first set are included in this second set. Red kinekna me second set එක include වෙලා තියෙනවා. So yes, we can say this first set is a subset of this second set. So we can say this is true. We can say it is true. Next one, it is some, I think, little bit different. Solution of 2x minus 1 is equal to 7. So we have to find the solution of 2x minus 1 equal to 7. So I think you can understand we are putting this. So 7 plus 1 is 8. 2x, x is equal to 8 divided by 2, it is 4. Here, in this first set, the solution is, or the set is 4. Only 4 is the element. Even numbers, if you write the even numbers 2, 4, 6, 8, 10, 12, like that way, you can go many more. So yes, definitely this 4 is inside this set. 4 is inside this second set. So we can say this 4 is this, or this set is a subset of this second set. මේ පළවෙනි set එක දෙවෙනි set එකේ subset එකක් කියලා කියන්න පුළුවන්. So we can say this statement is true. Yes, so this is the second part. Okay, let's move to the third question also, because it is also a well needed thing. So yes. Third question, write a universal set for the set A. So A is equal to A, E, I, O, U. So you can see here A, E, I, O, U, that means the vowels of the English alphabet. So how can we write? We can write all these elements inside the universal set like this way. So if you write A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. So if you write this alphabet, all these vowels are included in this English alphabet. All these vowels are included in this English alphabet. So we can write the universal set as letters of the English alphabet. Letters of the English alphabet. So I think you can understand it. They are asking the universal set. Universal set must include this all the elements and also another more elements inside this universal set. මේ දීලා තියෙන set එකේ තියෙන elements වලට අමතරව තව elements තියෙනවා නම් අපිට ඒක universal set එකක් විදිහට define කරන්න පුළුවන්. So here A, E, I, O, U, those are the vowels. I have taken all the alphabet, all the letters of the alphabet, English alphabet, A, B, C, D, E, F, G, H, I, J, K, up to Z. I have taken all the letters to this universal set. So I can name this universal set as the letters of the English alphabet. So I think you can understand it. So you can do the first question, next fourth question at home. So if you need, you can send me the PDF. I will check it and give it to you. So next one, it is a special thing. It is Venn diagrams. It is very much important up to O levels. So in your grade 10 lesson also, you have to learn about Venn diagrams. So please understand it well, and please try to get this idea very well about Venn diagrams. So we are going to write next the Venn diagram. So even if it is long enough this video, you can pause or you can stop from here, and you can have your something you can have an interval, and after that you can listen to this other part of this video. So after that we are going to discuss about the Venn diagrams. Yes, so now we will discuss about Venn diagrams. So shall we go to a topic, Venn diagrams? So I think you have learned about Venn diagrams in your previous grades also. So however, I will explain it here also. Sorry. Venn diagrams. So normally Venn diagrams are denoted by this way. The universal set is denoted by a square. Universal, not a square, it is a rectangle. Universal set is denoted by a rectangle, and there is, we denote this symbol here as this is a universal set. So we usually denote the universal set as a rectangle in this Venn diagram. So this is sorry. So this is the universal set, and we have keep this. So we have written this sign also of the universal set. So this whole one, it is the universal set. And if there is a set or if there is a subset, we can denote it by using a circle or a oval shape. So if I think there is a set A, if there is a set A inside this universal set, I can denote it using a oval, or you can draw a circle or a oval shape. So what you have to do is you have to name this one. This circle, it is set A. This whole rectangle is the universal set, and this circle is the set A. So shall we do a small example to understand it well? Yes, shall we take the example number 1? Example number 1. So this is the example number 1. So they have given the universal set is equal to 1, 2, 3, 4, 5, 6, 7. Next, set A is equal to 2, 4, 6. Represent the above sets in a Venn diagram. Above sets in a Venn diagram. Yes. So Venn diagram, first we are going to draw the universal set. So this is the universal set. We denote it by a rectangle, and here we will put this sign, the universal set, and there is only one subset. It is A. There is only one subset. It is A. So I will draw this one. So this is subset A. This is subset A, and you can mark here in this subset 2, 4, 6 is only there. So I can mark 2, 4, 6 like this way inside this circle. Next, if you see the universal set, there are 1, 2, 3, 4, 5, 6, 7. So already you have marked 2, 4, and 6. So remaining are 1, 3, 5, 7. 1, 3, 5, and 7 are remaining. So where should they come is, they should not come inside this circle. May circle like a ඇතුළට values එන්න බෑ. Outside this circle, there must be this 1, 3, 5, and 7. So I can fill inside this rectangle 1, 3, 5, 7 like this way. So you can write anywhere inside this rectangle, but not inside this circle. මේ circle එක ඇතුලේ නැතුව මේ rectangle එක ඇතුලේ ඕනි තැනක 1, 3, 5, 7 කියන elements ටික ලියන්න පුළුවන්. So this is how we can represent this data in a Venn diagram. So in your questions in the exam, they do not give a one subset like this. So they normally give two subsets. They normally give two subsets. So here only one subset. When we can take when there are two subsets. So when there are two subsets, there are few instances we must consider. That means the shape is little bit different. The shape is little bit different. So we can say it in 4 instances. Yes, we can tell it in 4 instances like this. So yes, this is the first one. Sorry. We can take here, this is the, sorry. Okay, sorry for that. Yes. When there are two subsets, we can take it like this way. So first instance is like this. There is the subset, sorry, the universal set like this way. Then there will be two subsets. So we can draw these circles separately like this way. So this is, I think this will be set A, and I will think this set will be B. So this instance means there are no any common elements for A set and B set. A කියන set එකටයි B කියන set එකටයි common elements නැහැ. So that is the instance which we can use this one. So we can write it A and B do not have common elements. A and B do not have common elements. Yes. So for next one, I will go for this one. The next instance. This is one circle and other circle. I can draw it like this way. So this is set A and this is set B. So they intersect in this area. They intersect each other or they overlay each other. Yeah, එක්කෙනාගේ උඩට යනවා intersect වෙනවා වගේ. So they intersect like this way. That means there are common elements for A and B. There are common elements for set A and B. So we can write A and B have common elements. A and B have common elements. Yes. So shall we move to another instance? So there may be some instances like this. This is the universal set, and we can take small circle and a large circle. So that means if I take this inside one A and outside one is B, so what we can say, tell this one, we can tell. So we have learned about this. So all the elements of A, all the elements of A are inside this set of B, are inside the set of B. So we can say A is a subset of B. So we can say A is a subset of B. So if A is a subset of B, we can denote it using this notation or using this diagram. Next one. So there are no two circles, both are on each other. This is A and as well as this is B. So yes, there are two circles, but they are on the other one. A and B are on the other one. So we can see only one circle, but there are two circles, A and B. So what is the instance we can say is, here, if they are on each other, that means all the elements are equal to each other. මේ දෙන්න අර එක උඩ වගේ එක තියෙයි නම් we can say all the elements are equal to each other. All the elements are same in both of these sets. So we have learned if all the elements are the same, we can say those sets as equal sets. So we can say A and B are equal sets. So these are the special instances where when there are two subsets, there are few instances like this. So I think you can understand it well. Okay. So here this yes, this sets lesson is a little bit lengthy. So what I have planned is I will do it in 2 days. 2 days means in 2 videos. So if I do it using one video, I think it will be very boring for you to watch all of this video, because I think it will take another 2 more hours, like that way. Not exactly 2 more hours. Nearly it will take 2 hours to complete all the lesson. So what I'm going to do is I will finish this video from here, and this is the part 1 of this lesson, and I will again record another part, and another part means the remaining part, and I will name it as part 2. So I will upload 2 videos for this lesson. So in the next video, we will discuss about the intersection, union and disjoint sets, intersection of sets, union of sets and disjoint sets. And after that, we'll discuss about the complement, yes, complement of a set. So those are the topics we have to discuss furthermore, and after that the lesson is over. So I think for this now this complement of a set, and the other topic is union of a set and intersection of a set and disjoint set. So those are very important points or very important topics in this lesson. Because of that, I'm not doing it all at once. So I will do it in my second part video, and here this is the part 1, and I will finish from here. And if you have any question, you can ask me anytime on WhatsApp, because this is a recorded video. So I will not get any questions from you when I'm recording this video. So because of that, I don't know whether you can understand it well or not. So if you cannot understand anything, please ask me on the WhatsApp, so I will give you the answer. Yes, so that is up to now, and I will stop this sets lesson part 1 video from here. Yes, so we'll back soon. Shall we see in the next video? Thank you.